Hello and welcome to Mathematics Solution. We are still continuing with calculus. And in calculus, we are looking at the methods of differentiation. And previously, we checked on the first principle, differentiation from the first principle. And I left an example, I left an exercise that was to find the derivative using the first principle given f of x is equals to x squared minus 1 over x plus 1. So this is by use, so it was to find the f prime of x using the first principle. So I want to expect that maybe you are tempted. Let us find the solution together here. Solution. So we said the first thing is to write the formula. We said that if y is equals to f of x and h is a small change, in x, then dy dx is equals to f prime of x, which is equals to the limit as h tends to 0, f at x plus h minus f at x over h. Sometimes you can put into bracket f at x plus h minus f at x, and all of it you multiply by 1 over h, which we shall still, it will still be expounding that you're dividing by h, definitely. So in this case here, we already have our f at x, which is equals to x squared minus 1 over x plus 1. So we need to find f at x plus h, which means that wherever there is x, we substitute with x plus h. So you're going to have x plus h squared minus 1, and this over x plus h, then plus 1. I want to believe, is it plus 1? It's supposed to be plus 1? This one here, it is. I think in the example, this was plus 2, the denominator. So this one, it is plus 2. And also here, it is plus 2. I'm following the example or maybe the exercise that I gave you. So this is plus 2. So which, when we expand this one, we shall get x squared plus 2xh plus h squared, then minus 1. Or this over x plus h, then plus 2. So we substitute now to our formula. So we're going to have f prime of x is equals to limit as h tends to 0, x squared plus 2xh plus h squared minus 1, or this over x plus h plus 2 minus f at x, which is x squared minus 1 over x plus 2. And so all these we multiply by 1 over h. Then from there, we put these fractions under one denominator. That means that we put and a single to be a single fraction. So you're going to find the LCM, and that one implies that you're going to multiply the denominators. Therefore, we have f prime of x being equal to limit as h tends to 0. The LCM we have simply said that it will be the product of x plus h plus 2. We multiply by x plus 2. So if you take this LCM divided by this denominator, we're going to remain with x plus 2, and we multiply by x squared plus 2xh plus h squared minus 1, then minus x squared minus 1. If you take this LCM divided by that, you're going to have into bracket x plus h plus 2. So let us expand this bracket. So you're going to have f prime at x is equals to limit as h tends to 0. So we have x into bracket x squared plus 2xh plus h squared minus 1, then plus 2 into bracket x squared plus 2xh plus h squared, and this minus 1, then minus x squared into bracket x plus h plus 2, then minus 1 into bracket x plus h plus 2. And all this, it's over x plus h plus 2 and multiply by x plus 2. Then we multiply everything here by 1 over h. So if we expand this, let us open up the bracket together. So f prime at x is equals to lim as h goes to 0 of x cubic plus 2x squared h plus h squared x minus x, then plus 2x squared plus 4x h plus 2h squared minus 1, then minus into bracket x cubic plus x squared h plus 2x squared, then minus x minus h minus 2. And all this, you're saying it's over the LCM, which is x plus h plus 2. Then we multiply by x plus 2. All this we multiply by 1 over h. So we want to open up this bracket. So we open up that bracket. So we're going to have f prime at x is equals to limit as h tends to 0, x cubic plus 2x squared h plus h squared x minus x plus 2x squared plus 4xh plus 2h squared minus 1. Then you open up the bracket with this negative. You're going to have negative x cubic minus x squared h minus 2x squared plus x plus h plus 2. And all this, it's over x plus h plus 2 and x plus 2. We multiply all this by 1 over h. We multiply it by 1 over h. So from there you can simplify. Let us simplify together. So we're going to have the x cubic, and the x cubic will go. We're also going to have minus x and plus x will go. We also have 2x squared and negative 2x squared will go. So do you have any other So this one is supposed to be 2. If you open up this bracket with this 2, this one will be 2. And so this one it will be 2, meaning that this 2 and this 2 will also go. So we're going to remain with f prime at x being equal to limit as h tends to 0 of 2x squared h plus h squared x plus 4xh plus 2h squared minus x squared h, then plus h. Then all this, it's over x plus h plus 2. And also, we have x plus 2, like that. All these, we are multiplying by 1 over h. So we need to factorize h and simplify further. So we're going to have f prime of x is equals to lim as h tends to 0 of h, then into bracket 2x squared plus h x, then plus 4xh, just plus 4 because we have already factorized h. So plus 4 x, then plus 2h minus x squared. Is it minus x squared? Will it be minus x squared h? X squared h, it will be plus, I think it will be plus. Let's just go back here. I read through. Let's just go a little bit up here. The x squared h, it's supposed to be plus. We shall see where. So let's just continue. Let us have it here. I think we're okay. It is okay, it is okay. So we factorize also 1 here, so it will be plus. It will be plus 1. Then all this over x plus h plus 2, and then x plus 2. We multiply all these times 1 over h. So this h here and whatever you have factorized, it will cancel. Also again, you realize that h is tending to 0. So wherever you have h, it will go to 0. All this will go to 0. So we remain with f prime of x being equal to 2x squared plus 4x minus x squared, then plus 1 over. So this one here, this h also will also turn to 0, so it will be over x plus 2 and x plus 2, so it will become x plus 2 squared. So 2x minus x, you'll have as x squared plus 4x plus 1, and this over x plus 2 squared. And that is the solution to that question. So the question number 2 that I give as an example, I believe that you are able to get because you have to differentiate 16 minus 4t squared. And I want to believe that you are able to get negative 8t, and when you substitute t with 2, you are able to get that the ball was decelerating. It was able to decelerate because the answer was negative. And it will become negative 8 times 2, which is negative 16 meters per second squared. So today, we want to look at the next method. The next method which is the product rule. So this is number 2, the product rule. So the product rule, it states that if y is equals to uv, where u and v are functions, they are functions of x, then dy dx is equals to v du dx plus u dv dx. Okay, so in some books you'll find that it has been written that y prime of x is equals to v u prime of x plus v plus u v prime of x. So we say that the u prime simply means the derivative. So this is the derivative of u with respect to x. So, but suppose y is equals to u, v, and w, where u, v, and w are all functions of x, then dy dx will be equal to uv dw dx plus uw dv dx and plus vw du dx. So this means that even when maybe you have a function which is a product of many functions and all of them depending on x, it is possible to find its derivative. So we want us to look at some number of examples. So examples. So we have example 1. Example 1, given example 1, given, so given y is equals to 2x plus 1 cubic, then x minus 8 raised to power 7. Find dy dx. So how do we go about this kind of a question? So it is very vivid to see that this y is a function, there is a product of two functions. There's this function here, and there's also this other function. We apply a product rule when we have product of two functions. So solution. So since we have two functions, we are going to assign one function to be u and the other one to be v. Therefore, we are going to apply the product rule. We have said product rule states that dy dx is equals to v du dx plus u dv dx. I'll give this reason why I started with v du dx plus u dv dx when we go to the next method. This is to make it simpler to remember or to memorize or even to understand. So in this case, we let our u be equal to the first function, which is 2x plus 1 cubic, and v be equal to x minus 8 raised to the power 7. So you realize that there's another problem here. If you differentiate du dx, there's another method that you need to remember so that you can be able to solve or to find the derivative of u with respect to x. And that is chain rule. And you have not covered chain rule. So meaning that this question we can be able to solve after we have gone through another step or another method known as the chain rule or function of a function. We shall attempt this question in the next method. Meanwhile, suppose maybe our y was, suppose maybe given, suppose maybe I've been given that y is equals to exponential 3t and exponential 3t sine 2t. So find dy dt. So how do you find dy dt? So you are going to apply the chain rule. So you have seen from the previous example that you have not completed, we have other method so that you can be able to find the derivative of y with respect to x. So in this case, let our u be equal to exponential 3t and our v be equal to sine 2t. So we're going to use the standard table where we say that the derivative ddx of exponential ax is equals to a exponential ax, and the derivative of sine ax is equals to a cos ax. So in this case now it means that our du dx will be equal to 3 exponential 3t. In fact, in this case, we are differentiating with respect to t and not to x. That's why you are finding dy dt. So du dt is equal to 3 exponential 3t, and dv dt is equals to 2 cos 2t. So we substitute to our formula dy dt. We have said that is given by v du dt plus u dv dt. So we're going to have dy dt is equals to, our v is sine 2t. Then we have du dt being equal to 3 exponential 3t plus, then we have u, which is exponential 3t, and then now we have dv dt, which is 2 cos 2t. So let us arrange and simplify. Dy dt is equals to 3 exponential 3t sine 2t plus 2 exponential 3t cos 2t. You realize that exponential 3t is common, and so therefore we can factorize and have dy dt being equal to exponential 3t into bracket 3 sine 2t plus 2 cos 2t. That is how we use the product rule to find the derivative. So let us have another example. Let us have another example. Example 2. Example 2. In this case, you have been given y is equals to 3x squared sine 2x. So find dy dx. So you realize that you'll not be told the method that you're going to use to find the derivative. So you are expected, when you see the product of two functions, like in this case, you have 3x squared, which is a polynomial, and a trigonometric function, which is sine 2x, then in such a product, then we have to apply the product rule. So let us find dy dx, again using the product rule. So we say that solution, we have said product rule states what? It states that dy dx is equals to v du dx plus u dv dx. So what do you think that you're going to let our u be and our v be? Good. So we let our v be equal, our u be equal to 3x squared, and our v be equal to sine 2x. Again, applying the standard table, we have du dx is equals to 6x, and our dv dx being equal to 2 cos 2x. So next is to do what? To substitute into our formula. So dy dx is equals to, our v is sine 2x, then our du dx is 6x, plus our u is 3x squared, then our dv dx is 2 cos 2x. So from there, we open up the bracket and arrange. So dy dx is equals to 6x sine 2x, then plus 3 times 2, which is 6x squared cos 2x. And that is our solution. You can end up maybe factorizing. If maybe you want to go an extra mile, you can factorize 6x. So dy dx is equals to 6x, then into bracket, you're going to have sine 2x plus x cos 2x. But even when you get to this point here, it is still okay. It's only that the final step here, We have simplified, and we have simplified by factorizing. So I want to give an exercise. Exercise for this one. So let me give you this exercise. Exercise. Given y is equals to exponential 3t ln of 40 and cos 3t, find dy dt. So the next lesson, we shall do the quotient rule. Thank you. Let us meet in the next class.